variance, discrete versus continuous. All right, two different formulas here. Once again, these are just on the formula sheet. Don't need to go through an example because all you're going to be doing is just subbing in values. Now, that being said, I will preface that with variance is a two-step thing. You'll get 2 marks for it. The reason being, you have to know the mean first. These formulas, what you'll notice is they actually involve nu. So this is the symbol nu, and what is nu? It's the expected value, it's the mean. So because we have to know the mean, you actually have to sub in the mean to this equation first. So for discrete, this is also in the data booklet. You don't have to memorize it. Worth writing down anyway. That's why I've put it in red as like it's worth writing down and trying to understand when you would use it. So if we have a discrete variable, for example, dollars, probably the best example. Like we had different winnings that you can get from casino. Well, we are going to be using this formula, and the probability should all equal one. That's part of this. That's a basic assumption that we've got here, right? All of our probabilities should add up and equal to one. We don't care about what the x's are, but all of the probabilities, the p's, should equal one. Now, what you'll notice, this discrete random formula, is similarly, so this is sigma, it means sum. Similarly, we're actually just adding up the probability times the x value, except we're doing two things. Number one, we're minusing nu, the mean, and we're squaring it, which is interesting. You wonder why. And my explanation for why this is occurring is ultimately, if we're talking about the variance, we don't care where it is. Like if you picture it as a scale, we don't care where x is. What we care is how much this interval here is. It like we don't care if it's here or here, but whether it's big or small. And so what we want to do is, um, we want to add the mean in because what we want to do is we want to see how much varies from the mean. We don't want to just talk about the x values because that's not an accurate representation. We want to subtract away the mean so that we kind of like standardize them. We make them uniform. That's my explanation for this, and hopefully that helps you to understand. But yeah, you'll notice that those are the only two changes. We're minusing the mean and then squaring it. So instead of just having the probability times x, and then we sum that up for all of the different values of x and their requisite probabilities. What we're going to do is we're actually going to minus the mean first and then square it. And this is on the data booklet. I do recommend writing it down just so you have a bit of an understanding. But yeah, whenever you see that sum symbol, if you're confused, all you do is you just sub in those values, and little I means that that's for one of them. For example, the probability of winning $10 at the casino is 0.5. However, the probability of winning $1 million is 0.001. You would have to then go all the way up to the $1 million value and go, okay, the probability is 0.001 times $1 million. And you would just add them up sequentially. That's how you do the expected value. When we've got variance, what we do is that million is going to be minus by the mean, and the mean is going to be like what, $8 or something? We would minus out the $8 first and then square it. And that tells us what the variance is. Similarly, for continuous variables, remembering anything like height, anything where it's a measurement, and that measurement has lots and lots and lots of little distinctions. What are we going to do? We are going to do this x minus the mean, but this time we're talking about it in terms of an integral. Once again, this formula is on your data booklet. So I haven't gone through an in-depth example here, but one thing to note again, you have to know the mean first. To work out, work out the variance, you need to know the mean. And so sometimes, you might have a 3-step question where it's like, oh, determine the variance, or it's 2 steps, sorry, and you're going to have to do the mean first. Just remember that. Don't get freaked out when you look at the data booklet. Just go, oh, that new symbol, that little new symbol, that means mean. So what am I going to do? I'm just going to find the mean first using the formula in the data booklet. Another example where clear working out is absolutely fantastic because you're going to be able to access those marks that are available to you much better. Okay, so the only difference here is that we're integrating. So in general, when we're calculating variance, it's kind of like x times um, probability, really. So it's kind of like the value times its probability. That's the general kind of like layout. Then we have little distinctions that are just on your formula sheet. For example, for variance, which is like how much it's varying, once again, we have x, so the value of x that we're talking about that's given here for variance of x minus its mean squared times probability of x. So whatever this function is, so it's going to be this times the function of x, because remember, with continuous, it can be described by an equation. And equations are like f of x or p of x. We would times that equation times x minus mean squared. And once again, this formula is remarkably similar to what? To this formula, where we're timesing x by the probability density function, this guy here. And what are we going between? The upper and lower bounds. And once again, look here, it's between the upper and lower bounds. So you just simply work it out, you simplify what's in there, then you integrate it between negative infinity, positive infinity, which is something that you should be pretty confident with from Unit 3. And if this was tech active, you would just plug this into your calculator. Obviously, you can't put infinity and negative infinity into your calculator. So what do? You just go 9999, you just type in like 10 nines, and it's going to be ridiculously accurate because these things, these probability density functions all have to approach zero anyway. So what you'll find is you're going to be accurate if you do that, even though, it's not technically infinity. It's approaching zero anyway, so at some point, it's pretty much accurate. So yeah, these are the formulas from the data booklet. Hopefully, I've given you enough time to write them down. Otherwise, like, ask questions in the live chat. I can drop links, screenshots, etc. I will be active 100% of the time, so just send me a message just on the live chat. And also, if you want more explanation or what you need to know, whatever it is, just let me know in the live chat. And I will note, this is what I meant to say. These slides are going to be available, not sure when, that's not up to me. However, they will be made available and you will be able to copy off these. And I would recommend 100% search them up on the website, go like July 2024 lecture series methods, go over these before you start revision and just like, it'll just refresh your brain because you haven't gone over these in so long, right? It's been so long since you've gone over these, and that's going to cause problems because you're not going to be confident on things. All right, standard deviation. This one, it's for both discrete and continuous. If you're asked for standard deviation, all you do is you um, do the square root of it. Now, this formula is not on the data booklet, and what that means is that you're going to actually have to memorize this one, unfortunately. Standard deviation is given by the letter or the formulation of, I'm not even sure what that's called. Maybe it's like omega or something, I'm not sure. But you have to memorize this formula to find the standard deviation because you're given the formula for variance between Bernoulli, discrete, continuous. You're given it for all three of those. However, you're not given the same deviation formula. And often questions, see how this can now be a three-part question that I've already shown you? Find the standard deviation for this data set, discrete or continuous. What you're going to have to do is, number one, you have to work out the mean. Number two is you have to work out the variance, then you have to square root it. Now, that can be extrapolated to a 4-mark question even if it's tech-free, because what you have to do is you have to do the integral. And that's worth a mark because there's room for error there as well. And you can already see how simple concepts can be extrapolated to a fair few marks, which, if you've learnt the content, are really going to help you pass. And you can definitely pass even if you're like, perhaps you feel like you're only standing on one leg at the moment, your internals haven't been great. This is the right time to pick up in terms of content. Even if you're failing right now, you can pass. I believe in you, and you should too. So therefore, we can say that the variance is equal to this variance would be equal to the standard deviation squared, and that's just rearranging this formula. But definitely write this one down on your data booklet, and it's something that you're reviewing the night before and just trying to memorize. Okay, you should be memorizing it before the night before, obviously, but it's something that you definitely need to revisit and is definitely worthwhile.